So this lecture is about finding suitable clays. So in this lecture, what we're going to look at, we're going to talk a little bit about clay mineralogy and the different types of clay. Then we're going to look at how we find clays in nature, and then how you can survey these deposits and estimate the clay reserves. Here we see the crystal structure of the main clay types. And you don't need to worry too much about the detail, but the important aspect to see in these clays is they're made of layers. And within these layers, we have aluminium surrounded by oxygen and silicon surrounded by oxygen. So kaolinite clays are different from all the rest because they're so-called one-to-one clays. This means that in each clay layer here, we have one layer of silicate tetrahedra and one layer of alumina octahedra. And this is in contrast to the so-called two-to-one clays, the illitic type and the montmorillonite type here, where we see now we have the alumina octahedra sandwiched between two layers of silicate tetrahedra. And because of this arrangement in the structure, this means that the two-to-one clays don't become as reactive when they're heated as does the kaolinitic clays. And this is what's very important and why it's important to have a certain quantity of kaolinite in your clay deposit. Here we see the structure of kaolinite in more detail. I mean, this basically says what I've already said, that we have these sheets made up of tetrahedra of silicates, octahedra of aluminates, and these two come together to form one sheet. The different sources of clay, there's a very important source of clays which can be waste materials from existing quarries. This is a separate, if you have waste materials in existing quarries, then you can just exploit the waste heaps, as we see here in the next slide. This is a quarry in India where they've been extracting clay for making ceramics, and this heap here is the waste. And quite often we find that these waste heaps contain quite high levels of kaolinite and can be very suitable for producing calcined clay for incorporating with cement. On the other hand, if you have a new quarry, this may look like this, and there's all kind of various material in this. Now, typically, after you've made the survey, you will see that there's a layer of topsoil on the top here. Then there's a very variable thickness of clay. Typically, this will be 20 to 30 meters thick, and then underneath we have the bedrock. And because this is, very variable depth, variable mineralogy, it's very important to go to the quarry and make a correct survey in the correct manner. So in this slide here, we see a schematic depiction of the different steps for surveying the quarry to the eventual mining operation. And this really means that you go from rather generic information on a large scale down to the smaller and smaller scale. And as you go down to the smaller scale, your degree of knowledge, of course, is going to increase, but so are the costs. So it's very important to do each of these steps in a systematic way, and at each step to assess whether you have the potential there to justify going further with extra costs and eventually to the mining operation. So this schematic here shows a picture of a quarry which is being studied in Cuba. And the first study made just these black bore holes here to really identify if there was kaolinite in this clay deposit. And then after that, they went back and they made a more detailed survey showed by these green spots here, which had a spacing of one, but these were just samples taken from quite near the surface. And finally, the full survey of the quarry was done at the red spots here. So this shows the kind of operation to, first of all, you need to take a trench and then take samples which you should take at the same depth. Then for the samples taken, you need to homogenize these together into composites, and afterwards go back and make some more detailed cores. As we see here in the boxes, here we see the cores. So this is the final outline of the quarry. As we saw before, we can see the variability of the depth of the clay layer, but we could also, from the detailed information from the cores, we can see that there is a variable mineralogy. In some areas there may be more calcite or less calcite. These are all other minerals generally which don't affect too much what the clay is doing, but there are some like calcite and sulfate bearing minerals you need to be a little bit careful about. Now, once you've done the initial survey and you've verified that you have kaolinite in your deposit, you probably want to then go back and estimate the reserve, because this is then a very important criteria for the financial viability of producing LC3. And this picture here shows you how you can use boreholes at different angles to then assemble a 3D map of the clay deposit. And once you have this 3D map, then this will provide information on the proven clay reserves. So just to summarize this lecture, what we've seen is that kaolitic clays are widely abundant, but if you need to exploit a new quarry, this must be done with a detailed field investigation. And in the next lecture, we'll see how you can then measure how much kaolinite is in these clays, and then afterwards the reactivity of these clays. So thank you, and see you next time.